All right, good day to everyone. Let's continue our discussion. Still on that chapter 4, resultant of force systems. Okay, so we're done with the two. Oh, wait. Yeah, I think it's two topics. Number one is moment of a point of a force about a point. Second was the application of cross product. Still on the computation of moment of a force about a point. Now, our next topic is moment of a couple. You know, sana all. A moment of a couple. All right. So, what is a couple? This is mechanics. It's not sociology or psychology. So, your definition of couple might be different from sa mechanics. Okay, so couple consists of two forces. So two, hindi pwedeng one, hindi pwedeng three. So couple means two, no? Consists of two forces that are equal in magnitude. So please take note. Equal in magnitude, opposite in direction, and have parallel, which means it's non-collinear. So wala silang intersection. It's not collinear. Hindi rin sila concurrent. Okay, that means parallel. Okay, they have parallel lines of action. So it produces a purely rotational effect. So it produces moment. Okay, so yan ang definition ng couple. So you need to take note, it consists of two forces that are equal in magnitude, opposite in direction, and have parallel lines of action. It produces purely rotational effect. So, yung couple produces rotational effect or moment. No? So, how do you solve for the moment of a couple? Very simple. Okay. So, example, we have a couple here. Force, same magnitude, opposite in direction, and are parallel. Okay. So the moment of this couple, okay, the moment produced by this couple is equal to the product of the force, magnitude of the force, and the distance between the two forces or the couple. Okay, so ganun lang kasimple. That's how we compute for the moment of a couple. Force times the distance between the two forces. So the distance would be perpendicular, of course, the perpendicular distance between the two forces. Okay, so that's it. Let's try to apply this principle. Paano ba mag-compute ng moment ng couple? Okay, so let's solve some examples now. Okay. Okay, determine the moment of the couple shown and the perpendicular distance between their lines of action. Okay, so we have this 400 Newton force couple. Yes. So this is 35 degrees, which means this should be 35 degrees also, no? Para parallel sila same magnitude, opposite in direction. So we are to solve for the couple produced, the moment produced by this couple. So there are, I think, several ways. There's modes ninyo, it was solved into, I don't know, several ways to solve for the moment produced by this couple, but we will just discuss one method or one way to solve the couple and the distance between the two couples, the two forces, I should say. So what we need to do, we're going to use the Variance theorem or the principle of moments, which means that the moment of a certain force about a point is also equal to the moment of its components to that particular point. No? So we're going to resolve. I-resolve lang natin ito into two components. So, ito parallel. Of course, yung 400 Newton force ay parallel, no? Ito parallel. ito naman parallel, no? So, dalawa. Yung moment nito, itong couple na to, and yung moment nito. So, add lang natin yung moment ng dalawang components. Alright? So, first we need to solve the components. Let's say this is fx, fy. This is also fx. This is also fy. So, fx is equal to 400 cosine of 35 degrees. That is equal to 327.661 newtons. And Fy is equal to 400 sine of 35 degrees equals 229.431 newton. So those are the components of the force. So parehas lang sila dyan, Fx, Fy. Then solve for the moment. Again, ang sign convention natin is clockwise positive, counterclockwise negative. Right. So the moment now is equal to, let's start with ito, moment ng Fx, ito yung couple, no? Fx, Fx. So sabi doon, yung moment ng couple is just equal to the product of the force and the distance between the two forces. Okay? The two couple forces. Alright. So, Fx produces, ano bang ang rotation niya? So, imagine, you just try to imagine, animate it in your minds. So, ano yung rotation produced by this couple? Okay? So, para mag-rotate siya ng counterclockwise. So, negative siya, no? So, negative, Fx is 327.661 newtons. Times yung moment arm, which is the distance between the two forces, okay, that is 200 millimeters, or that is, let's say 200 mm. Okay. And then, ang isa pang couple ay, Fy. So, Fy, same magnitude, opposite direction, okay, parallel. So, it produces a, ano, imagine ulit, Fy, pag ganun, counterclockwise din, ano? So, counterclockwise yung na-produce na moment. So, minus, Fy is 229.431 newtons times its moment arm. Moment arm is the distance between the two forces. Alright, so that is equal to 100 millimeters. Sorry, that should be millimeters. Okay. So the moment is equal to negative 88,475.3. The unit would be Newton millimeter. Alright. Or that is equal to, equal yan sa, so there are 1,000 millimeters in 1 meter. So mag-move lang tayo ng decimal places. Tatlo, ano? So we have negative 88.475 Newton meter. Pag convert natin siya sa Newton meter. Or that is equal to, so 88.475 Newton meter na counterclockwise. So you may remove the negative sign, but you have to indicate yung direction ng moment, which is counterclockwise in this case. So next is to solve for the distance, the perpendicular distance between the two forces. So M, remember, M is just equal to F times distance. Okay, so we know F is 400 newtons. We know the moment is, sabi kanina, di ba sabi ko sa principle of moments, sa Vreinen's theorem, yung moment ng force na ito, okay, yung moment ng dalawang yan, yung couple na yan, is also equal to the moment of the components ng couple. Okay. So parehas lang sila ng moment. So we have 88,475.3 This is Newton millimeter equals force, which is 400 newtons, times distance, which we do not know. No? Newton millimeter. So, cancel yung newton. We're left with millimeters. So, solve lang natin. Cross multiply. Distance is 221.188 mm. Okay. So, this would be our answers for this example or problem. Okay. Next example. Okay, two parallel 75 Newton forces are applied to the lever as shown. Determine the moment of the couple formed by the two forces. So we have these two forces, couple. Solve for the moment produced by this couple. And again, we can use, I think the module presented, na-present doon, I don't know how many methods. I think 3 methods to solve for this particular problem, but we will just discuss one here. No, just discuss one. Anyway, okay. If you want to study the other methods, just look into your module. So, nandun yun. The component methods. Again, we're going to apply the principle of moments. No, so we're going to resolve this forces into components. Oh, sorry, mali yung direction nito. That should have been upwards. Yeah. Yeah. Okay, we're good. So this is fx, fy, fx. Okay, that's it. Okay, so yung mga couple, so dalawa lang, no, itong 75. Pero since na-resolve into components, naging dalawa na yung couple natin. So, isa kanina, dalawa na because we have resolved it into components. So, fy couple, fx couple. So, basically, the moment of this couple is also equal to the summation of moments of couple of fy, the moment of fy, okay, and then the coupled moment of fx. Ayan. Alright, so let's solve muna yung components, fy and fx. Fx is equal to 75 newtons yan. Okay, adjacent. So, kung 30 degrees yan, 30 degrees, 20 degrees ito, 20 degrees din ito, ano? Yeah. So, 75 cosine of 20 degrees, that is 70.477 newtons. And Fy is 75 sine of 20. It's equivalent to 25.652 newtons. Okay, so solve na tayo sa components. Now we are ready to compute for the moment. Now, one problem pa pala is the moment arm. So distance ng Fy, distance between the two Fy's. Ano? Distance between the two Fy's, ito. Itong distance na yan. And then distance of between the two fx's. Ito. So, ano yan? So, triangle. No? Gawa lang tayo ng triangle. So, So, saan yung ating triangle or right triangle? So, pwedeng ito, right triangle yan. Right triangle din naman ito. If you're going to use this, ayan. So, right triangle, okay? If there's 55, this is also 55 degrees din yan. Okay? Alright. So, maybe we can use this triangle na lang. So, ito yung ating distance between fx. Ito, yung vertical side ng right triangle. And then, yung horizontal side ng triangle, right triangle natin is the distance between fy. No, yan yun. Okay? So, ulit tayo. Diretso lang natin sa computation. Okay, so the moment then is equal to, let's start with fx na lang muna. So fx, it creates a clockwise. So you look into the sa arrow natin, directed pa ganun yung fx, pa ganun din naman ito, opposite syempre. So yung rotation niyan would be clockwise, so positive siya. So we have fx is 70.477 newtons times yung moment arm, yung distance between the two forces. Ito. So this is 360 degrees. 360 millimeters. Okay? 360 millimeters yan. So we are solving for itong vertical distance natin. Okay, so ano yan? How do you compute for vertical distance? Oh, ito yung angle natin na 55. This is the opposite side. So sine. So we have 360 mm sine of 55 degrees. Ayan. So yan yung moment arm ng 70.477 Newton force. Or that is Fx. Then, moment naman ng Fy. Fy, ganun yung arrow, direction ng arrow. Okay, so if we try to imagine, that would produce a counterclockwise moment or rotation. Counterclockwise rotation. So, negative siya. So, minus, so Fy is 25.652 newtons. Times yung moment arm ng yung distance between the two forces here, which is the moment arm. Etong distance na yan, ito yun, yan din yun, adjacent side. So, we have 360 mm cosine of 55 degrees. Ayan. Okay, so yung moment natin ay that is equivalent to 15,486.485 Newton millimeter, or that is equivalent to, so positive siya, so ibig sabihin clockwise yung direction. So if you want to convert this to Newton meter, mag-move lang tayo ng 3 decimal places since there are 1,000 millimeters in 1 meter. So we have 15.846 Newton meter. So this would be our answer for this particular example or problem. Okay. Okay, we'll have another example in a separate video.